I'm Anil Kumar, and in this video, we will learn a very important concept of vector projection. The question here is, draw a diagram to explain why projection of vector A on B is equal to projection of vector A on projection of vector C on B. That's the question for you. You can pause the video, think about it, answer, and then look into my suggestion. Let me answer this question with the help of a two-dimensional figure R2. So let's consider the vectors A and B in XY plane. For simplicity, I will take vector B along x-axis. Okay, so let us say this is my vector B. Right, so I'll just call this as my vector B along the x-axis. Now when I say projection of vector A on B, what does it really mean? Let us say this is vector A. Right, let me call this as vector A. Now projection of vector A on B is as if you put a light here, the shadow of this falls on B, so that length, let me call this ON. So ON becomes the projection of A on B, right? Let's say this angle is theta, right? So I can write that the projection of A on B in this diagram is ON in the direction of B, right? So ON, and the direction is unit vector B. So I've taken unit vector B. ON is the magnitude, so let me write this as magnitude, right? In the direction of B, unit vector. Let's say this is the unit vector B. And of course, you understand what unit vector is. Magnitude, when you divide this magnitude of B, vector B by its magnitude, you get unit vector in the direction of B, right? So that is the vector projection of A on B. So this is our left side. Let me say left side. Now let's think about projection of A on projection of C on B. So let me sketch a vector C now. Let us say this is the vector C. Okay. If this is the vector C, then the projection of C on B will be what? That is the projection of C on vector B, correct? Let me call this as OP. Correct? So this is OP, and that's the magnitude, and direction will be in the direction of B. So let me write unit vector B here. Correct? So that is the direction of the vector OP, which is projection of C on B. Perfect. Now, so what we have here is that projection of C on B, B, is OP, and it is in the direction of B. Is it okay? Right. Which we could represent as this. Okay, that's the projection of vector C on B. Now, what is the projection of A? What is the projection of A on this? A on that, that means, correct? So now let's look into projection of A on vector OP. Let's say OP, right? Vector OP is okay. We have the magnitude and the direction, vector OP. Now the projection of A on vector OP is still ON, right? You see that? It is still ON, where ON is the magnitude and the direction is in the direction of B, right? So I could always write this as the vector ON, right? So vector ON has a magnitude of ON in direction of unit vector B, right, in that direction. So in both cases, what we see here is that the right side is also equal to the vector ON, and therefore we can say that the projection of A on B is same as projection of A on C on B. I hope that's absolutely clear, right? So in both cases, as you can see, that the projection of A is ON, the vector ON, perfect, which has a magnitude of ON, and it is in the direction of B. I'm Anil Kumar, and I hope that helps you to understand the whole concept of projection. You may like my videos, share with your friends, and post comments. Thank you, and all the best.